So I don't know how this is going to go, but maybe we can use them and put them online, and you can look at them later if you look at them. Okay, so we had this. Just a few words about the class. It's a beginner's class. We're going to go and cover everything basically from the absolute basics of Matlab to doing your own scripts and functions and to analyze and display data and do many more things. And the goal is it's very hands-on. So right now you're looking at me and I'm giving a presentation, but it's going to be only a small fraction of this class. Okay, most of the time you're going to do and type your own code, and we're going to give you exercises, and we're also going to give you exercises to do at home. I'm going to tell you something about this exercise, don't worry. So when is this class happening? Well, we have 8 sessions of 2 hours each, always in this room from 4 to 6. However, the days of the week, they change. So this week it's Monday, Wednesday, and Thursday, and next week is Tuesday, Wednesday, and Thursday. And then on the last week, we only have 2 sessions, Tuesday and Thursday. And the reason why it changes, the day of the week change, is due to constraints of this classroom and then our own schedules. Okay? So just remember, it's not always Monday, Wednesday, Thursday. It changes. As I said, it's mandatory for first-year PhD students, and you don't get an exam, you don't even get a real grade, but you're going to get the homework, and we strongly suggest that you do the homework by yourself. I mean, you can also ask us, and we're going to help you, but you should sort of, try, and that's the only way you learn. The homework, by the way, we thought about giving 1 for each week. So not 1 for each session or class, but 1 per week. And most likely we're going to give it to you at the end of the week, and we're going to give you 1 week to do it. It's not going to be extremely difficult, extremely long, and it's mostly going to be based on, what we taught you. So you're supposed to be able to do it, and it helps you to practice. Okay. And if you ever have questions, just ask. This is very informal. Yeah? The outline for this first session goes like this. We're going to look really from the basic, what is Matlab, how do you open it, what are different windows. How do you get help if you have questions in Matlab. What are the basic operators, functions, and predefined variables, which data types can be used using Matlab. And then how do we create and concatenate and index and change elements of numeric arrays. Something which I didn't maybe say before I start with that is that we want to do the course like that. Basically, in every class, there's going to be 1 hour of me or Amir talking. But it's not just me talking. You can ask questions, and some point it will become more interactive. Okay. And then the second hour, you can have a break in between. The second hour, it's going to be really hands-on. You guys typing your code, and Amir and me, we're going to come and help you if you need, so that you really spend a lot of time working on code. Okay. So Matlab stands for Matrix Laboratory. And it was developed in the early 70s by Yves Moeller, who was professor of mathematics and computer science in Michigan. And now it's part of this company called the MathWorks. It costs money, actually. This is maybe not the most up-to-date price, but it's in the range of $90 for students, so let's say 70, 80 euros. And about 500 for academics. Luckily, CISA has some licenses. Actually, they only recently invested in getting enough licenses for all of us. So that's really good. I already gave you in the email. You already had the link where you can go and install it on your computer. You can even install it on several computers at home. Obviously, try not to install it for every aunt and cousin. Okay. And then there's also a free version of Matlab, which is called Octave. And I have to admit, I never really use it. I don't know how many of you use it. Isn't it?
Not free version. It's like some open source
like
communities have implemented the same functionalities, but the core of Matlab, not the toolbox.
Exactly, yeah. So it's wrong to say it's a free version. It's just like when you don't want to pay for Microsoft Office, and you use...
No, it's very similar. Like I said, like the core program is similar, but it doesn't have toolboxes, which are the main point of Matlab.
Yeah.
So you have the code functionalities, but not the.
So maybe it's still worth checking out, and if you really need to run a script and don't have Matlab, maybe you can simplify it and run it there. But most of the time you will be in a university where people will pay for a license and you can use Matlab.
No, but also these licenses, there are some offline licenses you can install. I think they can, right?
Yeah, there's a link here.
Yeah, so you can actually use them also. Because before it was like you have to, the license had to
you need to
verify online. Yeah, but now it's fine. You can install a standalone version.
Exactly. Yeah. So it works even without internet. You once a year or so have to activate it, and then that's it. Okay, yeah. So we just heard the word toolboxes. Because that's the point. Matlab actually consists of the main program and a bunch of toolboxes. And these toolboxes are pretty important. We're going to talk about the statistics toolbox, but there's other ones which might be important for your work, signal processing or image processing. And you can get an overview of the toolboxes if you go to mathworks.com. Then on top of that, there's some toolboxes which users created and which have become sort of well known for certain aspects. So, Cycle Toolbox, for example, is used a lot to, say, present pictures or stimuli precisely in time to do psychological experiments. Same thing with Cogent. I know that some of you are using Cogent, which I don't think it's supported anymore. Right, locked down, but it's still used a lot. So you might read articles where they use Cogent as like a toolbox. EGF and SPM are well-known toolboxes to analyze EEG data or fMRI data. But there's more, okay? And if you ever want to do something on Matlab, first try to see if there's a toolbox for it. It might save you a lot of time. So why do we need Matlab? Well, we can do many things with Matlab. You can manipulate matrices, you can plot functions and data, we can implement algorithms, create user interfaces, and Amir is going to show you over towards the end of the class how to do it. Interface Matlab with other programs like C, C++, Java, and Python. And so I'm, as I told you, a cognitive neuroscientist / psychologist, so I can tell you from my perspective why that's important. Well, you can create stimuli, visual stimuli like pictures or audio stimuli, and control them on many dimensions, say luminance, power, and spatial frequencies, etc. You can program your experiments, for example, using Cycle Toolbox or Cogent, as I said before. You can acquire the data, you can pre-process the data, plot the data, and do your statistics. The only thing it doesn't do basically is write the article. You still have to do it on your own. Importantly, if you compare it, I mean, some people, and there's no shame about it, but some people are still working with Excel, and they have lots of Excel sheets, and then they have to transfer data from one side to the other, etc. Well, you can do that, but it's going to take a lot of time, you might make mistakes, and if you ever talk to somebody who tells you, but have you tried to analyze it this way? And you'll be like, oh my god, I need to redo everything from scratch. That can be quite frustrating. But in Matlab, once you have set up your script, you can rerun it with simple modifications and it runs by itself. So, it's more flexible and faster, and you do fewer mistakes. And yeah, as I said, it's very important to analyze brain data like EEG and fMRI. Okay, still you could ask, do I really need this? I could find somebody else. Indeed, yes. If you so you need MATLAB if you want to do research that uses more than simple questions as an Excel graphs, especially if you use physiological data. However, if you are already an established professor, well, basically just pay somebody to do it for you. However, talking of established professors, Molly Crockett is somebody who is a young professor at the University of Oxford and has an amazing CV, and she's beautiful and she's everything. And when you ask her, actually, I read this in a recent interview, like what advice would you give to an early career social neuroscientist, because that's how she defines herself, social neuroscientist. Well, her answer is, invest time in learning a programming language, for example MATLAB, and advanced statistical modeling. Find a research topic that few people are working on, but is likely to become popular in a few years. And there's some luck involved in this. So, learning MATLAB definitely is her advice for early scientists in this field. Therefore, that's the answer. Huh? And some more arguments for learning MATLAB. For me, it became evident when I started to learn MATLAB that it also will happen with other languages. Just, for example, I studied programming in R, which is more used by psychologists, I guess. Powerful for statistics and graphs. Some of you might know E prime, presentation, Python, or even MS-DOS and a shell in Mac. The logic is often similar of these programming languages. And this comes really from somebody, as I told you, who is not a computer guy. I didn't learn this the proper way. But you see patterns, and if you learn one language, it will help you with other languages. So it's really good to start with MATLAB if you have the occasion. And if you learn another language, maybe it will help you to understand MATLAB. So how do you really learn MATLAB? Well, you come to this class, you do your exercises, you do your homework, okay? Then, if you want, this is kind of funny, you can go online and see examples of people who use MATLAB for literally everything. So listen to online music, they program stuff to entertain their cats with lights moving on the screen. They use MATLAB to build a baby phone. It's amazing what people come up with. And then there's many online courses and tutorials. And here's just a list of them. And also on the Mathworks website, you can find very good videos. So sometimes you don't want to read, you're tired of reading. You go and listen to a video, it's perfect. There's also YouTube tutorials, of course. Books. Here's just a few of them. Okay. And writing code can be fun, believe me, because so a little bit more of anecdotal stories. I actually, not only I'm a psychologist, but I come from the least, if you want, programming and scientific domain of psychology, okay? And I always thought that I would be working more in the humanities. Well, starting MATLAB put me into a world where sometimes you fight for hours or for days with your code, but once you hit a button and it runs and it works, you get this feeling like, oh my God, I'm God, and this is just too beautiful. So it is a lot of fun. But importantly, in the beginning especially, you shouldn't put your aim too high. Okay, you just want to use it as a tool to do something, and there's no right way to do that. If it works, it's fine, right? You can always later on improve it to streamline it. You can annotate it so that you can pass it to other colleagues, or that yourself, when you come back to a script a year later, you scratch your head and go, why did I do this? What am I doing? But if you annotate it, if you put comments, you might remember better. And then you can start making scripts which are more flexible. So in the beginning, maybe it only applies to that specific set of data. But then you can create functions where it can take different sets of data and do different things. And it can run faster. So all this is good, but in the beginning, you just want it to work, and don't be ashamed to ask colleagues for their scripts. You know, they can always say, no, I don't want to give it to you, but just ask a colleague, oh, do you have a script in Matlab that I can reuse, that I can recycle? Because we all do this, even advanced, even Amir, I guess, right? Even advanced programmers. No, I mean, you don't necessarily take it from somebody else, but you might reuse your own script and then change it
It's
to
actually
something
like
else.
a nice practice to even put your code up like on your website for others to use it. If you have a method, I mean, so many people actually it helps like to get more citations because they can use your method and then cite your paper.
Yeah.
So that's
That reminds me that I should set up a website. But yeah, I mean, for example, when I have to analyze a new set of data, I don't start writing an entire script from scratch. I go and reuse pieces of other scripts, and so I can do it with my own scripts or with somebody else's scripts. It's always easier to do that than to rethink everything from scratch. Okay. Then just one small thing. Most of you now, well, you have a Mac, but I guess most are using a PC. You also have a Mac. There are some small differences between using Matlab on a Mac or on Windows. And so far I mostly found them linked to the functions which go and read from or write to Excel. Okay, because that interacts with Microsoft Office, and obviously that works better on Windows. So that's one difference. And if some things don't work, when you try to do on a Mac, Excel is write or Excel is read. But if it doesn't work properly, it's maybe because you're using a Mac, and there's no way around this, but there are solutions. Questions? No? Good. So I hope that by now you all have Matlab open in front of you, or you can at least open it now. Well, I put two different versions here because I had them on my computer, but you probably have the version R 2015B, is that correct? Can you look it up?
Yeah.
Okay.
Mine.
So, yeah? No? You guys don't have it?
The 2012.
That's what you guys have?
I have it.
But what are you using? Laptop? I'm using laptop. Okay.
B.
And the ones with the computer, you have 2015B. Okay, good. So some things I'm showing now mostly for the newer version. Some things maybe don't apply to your older version. Doesn't matter so much. Okay. So you can customize a lot the appearance of Matlab. For example, you can show or hide or change the size of the windows. You can undock them, because right now they're probably clustered together. You can undock them, undock them back, and you can change the colors of the background and the text. For example, I put it like this because it looks more badass. So I think in the coming slides, it's often going to be black. That just means I change the colors, and you can do the same if you want, but you don't have to. So what do we have here? We have also, if the position of the windows doesn't look exactly like this for you, it's because you can move them around, and you can. I invite you while you're listening to you can click on this and drag it over here and see what happens, this kind of things. But anyway, we have one window which is called current folder, and well, it's pretty straightforward. It tells you where you are in your computer, okay? And you're going to see the data that is in there, if there is any. You have another little window which is called workspace, and that's sort of like a memory buffer. Okay? Everything you will create in Matlab is going to appear here. Every data you're going to upload, every graph you're going to do, they're all going to be in here. And then there's one big window, which is the command window. It's the main window we use to interact with Matlab. There's going to be more windows later on. I talked about undocking. There should be this little triangle. And if you click there, maybe there's the option undocking. which allows you, to make it a separate window. Because sometimes, especially if you have a small screen, it gets annoying to have it all together. So here again, just to tell you, we have the command window. What can you do with the command window? Well, you can change the directory. I'm going to tell you later how to do. You can type in Matlab commands. You can run scripts and functions. It gives you an echo, so it gives you it tells you what it's doing. And it tells you when you're doing things wrongly, so it gives you error messages, usually in red. Then the current folder workspace window, well, you can see your files and the variables you created. And then maybe you have another window. If not, there's a way of making it appear. It's called command history. And that lists all the commands which you have entered so far in the session. And it can be handy because it allows you to basically go back and see what you did and copy something and paste it, for example, in your command window. So if you created a variable and you want to see it, the nice thing is that you can in Matlab. So if I created A, and it's in my so-called workspace, if I double-click it, it actually will open this other window here, which shows me that A has 2 lines and 20 columns, and there's a bunch of numbers in there. Okay. You can use the editor to also create scripts and functions, which you can save them. So what is the editor window? Well, it's another window that maybe you haven't yet opened. And to open it, at least in the last version, you go here on New, and then push Script. Yeah? This should open an editor window, which again you can dock or undock. So you can have it separated, undocked, or integrated in this big method. And that's so the difference between the command window and the editor window is that if you want to do something and save it for later, you better do it in the editor window. Then you can save it as a file. Basically, it's like a text file. And you can open it later on and run it. Well, everything you do here is you don't save it. You lose it, basically. Okay, then if you have all these windows, and especially if you then create pictures and figures, you're going to have a lot of windows and you have to switch between them. And, well, I can give you this a tip if you're using Mac, because that's what I am doing. I use a shortcut to switch between the windows of the same program. And you can activate this shortcut by going on, how's it called? Preferences, and then not of the Matlab, but of your Mac preferences and keyboard, and activate this shortcut. That's handy if you have to switch between windows. Okay. So now, what about the current directory? You remember there's a window which is current folder, telling you where you are on your computer. Well, you can change the directory where you are, either by modifying it in user-friendly way here, okay, or by going into the command window and typing pwd, okay, present working directory. That tells you where you are right now, and everything I say here you can try out. If you see this other font, okay, it means that these are actually programs entered in Matlab. If you see 2 arrows, that's basically because we are in the command window and given this command. Yeah? So if you type pwd, you should get, probably you are now in home Matlab, something like that. I don't know where you are. Yeah? And you can see everything which is in that working directory if you type ls or dir, one of the 2. And if you want to change directory, well, you can say cd, and then as a given it here, you give your new name of path. So say you are in a folder called Matlab Class, and we'll go inside of another folder which is in there, which is called day1. So you would say cd, and then you give all your paths ending with day1. Does it work?
No. Ls here is not.
Either ls or here.
Yeah. Yeah, so I should write it. It's one or the other.
Okay.
By the way, can I just, if you're trying and you can't, you can just ask him, because he keeps talking, but it's like for because you're supposed to try these things because it's easier than
Okay. So in case Amir can't help you because he's busy with somebody else, or you're at home, you can always get help from Matlab. Yeah. So if you already know a certain function name or command name, you can just type help space and then the name of that thing. Say for example square root is sqrt, so help sqrt. Or length, which is going to tell you how long a vector is, help space length. You can also use something which is even nicer than that, because if you type help and something in the command window, it's all running one below the other. You have to scroll up, and it's not so nice. It doesn't have pictures, for example. But if you type doc space in that same function name or command name, then it opens up another window, which is much nicer looking and has pictures and examples, and maybe you can do it and you see better what we're talking about. Some other things you can use. Look for, so when you search for help for a keyword, that's maybe useful when you don't know exactly how the command is called. You can get a list of general commands with help general. Help on help, I don't think you need this. And then there's some really nice demos. If you type demo, you're gonna get to them. And a complete help system containing full text of manuals is started by typing help desk. You should get something similar to this. And so the help manual in Matlab is really, 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 really good. It's going to help you a lot. This is something I found out by upgrading my Matlab also to the latest version. And now in the command window, you actually have just next to this double arrows, this prompt, you have a little function button, which is similar to the one in Excel, for example. If you click it, you can scroll through all types of commands. And so that can be handy. Also, if you want, Matlab can save a diary, which is basically, it keeps track of everything you do. And it might be interesting for you to do it, for example, if you go in a certain directory now, you create your own folder for this Matlab class, and then in Matlab, in the command window, you type diary, and at the end of the day, you're going to type diary off. It's going to save a file with everything you've done today, and that can be interesting. You can use it maybe if you look at your object done tomorrow or so. Yeah, that's what I just said. Okay, sometimes Matlab, even though it's good programming, it crashes. In that case, you try to go in the command window and type Control-C, Control-C, Control-C until it should stop, usually. If not, well, you know what to do. Abort with, what's it called actually?
with control.
Task manager.
Task manager, exactly. Okay, so that was really the basic introduction, and now we're going to jump into creating variables. Any questions so far? Any problems? Good. So how do you create a variable? It's very simple. You type the name of the variable equal and whatever you want to put into it. So for example here, you're going to create a variable called x, which contains the number 1. It's directly created a variable. You don't have, in other programs you have to assign memory or these kind of things. You have to say what type of variable it is. Here you don't need to. And if you do this, it should look exactly like this in the command window, meaning that once you create a variable, it spits out the name of the variable equal, and underneath it shows you the content. Right?
Yeah.
Okay. And then you can add something to that variable because the variable is a number. So you can say x equals x plus 1, and it should give you the result right away, which is 2. The same thing works with multiplication. So you can say now y equals x times 3. So because x became 2, if you do it times 3, it's 6. And if you don't want to see all the time the output of your variable or the content of your variable, you just need to put semicolon at the end of your command. So here type y equals 10, semicolon, and then there's nothing happening, no output. If I want to see what is in y, I can now just type y, enter, and it shows me then the output, which should be 10. Yeah? Is that clear? Yeah, for you guys in the back, it's a little bit low, huh? The screen, the bottom of the screen. So maybe you cannot even see that. The space before and after, for example, the equal sign or the plus or the times sign, that's all optional.
Okay.
Yeah? You don't need to have exactly one space. Some other stuff you can try out. Okay, so the workspace you already remember is the sort of memory where everything that you created goes into it. Huh? And you can go in there and double click on stuff, and it also should indicate to you actually right away the type of variable it is and the dimensions. But one other way to do this is to go into the command window, and if you just want to know which variables you have, you can type who. Yeah? And these are the variables I have created in this example. So I have 4 variables, and it just tells me the names. And maybe you only created x and y, so it should tell you x and y. If you add an s to who, you should get a more precise description. So it gives you the name, the size, which is always the number of rows by the number of columns. That's important to remember. Always number of rows by number of columns. Tells you how much memory it takes and which class it is. You're going to talk about the classes later. But basically double means numbers. Okay, now maybe you want to get rid of a variable that you created. How do you do that? You can say clear space. So here the space is not optional, by the way. Clear space and the name of the variable, or the name of all the variables you want to clear. Yeah. So you can say clear x space y space whatever you want to put. And you can also do clear all, and then you just get rid of everything, which can be a problem. Huh? If you do clear all and then you remember, oh, I needed something, well, it's gone. You have to redo everything. Watch out, because Matlab is case sensitive. So, first of all, variable names must start with a letter. They cannot start with a number, for example. Okay? And variable names must contain letters, digits, or underscores. They can contain this. Do not use space when naming variables, files, or folders. So maybe for files and folders it will work with space, but a good habit is to never put, when you call your, for example, Matlab Class 2016, put underscore instead of the spaces. Don't put, for example, CISA apostrophe S Matlab class. That's going to create problems. If not with Matlab, with something else. So just try not to put any spaces or weird signs in your folder or variable names. Another thing which is important is that the same matter is case sensitive. So if I call a variable FOO, which is, I actually don't know the reason, but often programmers use this to say some standard verb. Can you?
Historically,
It's
so
historic.
funny. Yeah.
Okay. So if you create the variable foo, but all in small letters, and then you want to do something with that variable foo, and you write it capitalized, well, Matlab is gonna give you an error. It's going to say undefined function of variable foo capitalized because he doesn't know what it is. He's not that smart to know that you just, wrote it capital and not wanted it small. Okay. Okay. So now we're going to talk about the basic operators, functions, and variables. Obviously, you can add, subtract, multiply, and divide, or take the power of something, power of 2 or whatever. And there are some functions which are basic and built in and which are very handy. So you want to do the sum of something, take the square root of something, have the absolute value. So if you have positive and negative, say EEG data, and you only want to say the positive, so you see everything in positive. You take apps, exponential, logarithm, sine, cosine, etc. And there are some variables which are predefined. So if you type pi, for example, in Matlab, you should get this number. Infinity, NaN, so that's important, can also be spelled in small letters, which means not a number. And then ANS, which means last answer, and whenever you create a variable or you do something without giving it a name to, we'll go into a new variable called ANS, as we will see later. Which are the data types in Matlab? Okay, so all data is stored in arrays / matrices, and an array is a variable with another name in the workspace. So each array has another name. Yeah? There are like two basic classes. Some arrays can only take one type of data, say only numbers or only text, while other arrays they can take data from different types. Yeah? So let's look first at those who can only take one type. You have, for example, numeric arrays. They can only take numbers. As per default, they're stored as double precision floating points. We distinguish between a scalar or an element, which is basically a single number. A vector, which is, if you want, just a column or just a row of numbers, one after the other, and the matrix. A matrix, which I think you know, is, for example, a two-dimensional matrix of many lines and many columns, or it can be three-dimensional. We then have arrays which are char, of type char. They are basically text strings. And then we have logical arrays which tell you if something is true or false. Okay, these are the ones which only take one type of data. Then there are those who take several types of data. Let's start with one which is new also to me, because it was only introduced in one of the later versions of Matlab. It's called table, and it's actually really, really cool. You can take numbers, but it has names for each column and each row, for example. So that can be handy if you do research, right? You're going to have different rats or different subjects, and they all have a name on different days, and you get your data, say physiology or some neuron spikes. You can have cell arrays, so they are amazing, they take everything. You can even put a cell array into a cell, a cell into a cell array. And then you have structures which are some sort of hierarchically structured systems of varying classes and sizes. Okay? This reminds me that we need to do some slides on structures. Can you pass over here afterwards the paper with the pen where you put hopefully your name and stuff? Good. Oh, the pen was very nice, so I went back. Thanks. Okay. So how do you create an array? You use, as before, you give a name for the variable, let's say x equals, and then you use the brackets to create an array which is going to contain here the numbers 1, 2, and 3. You can, if you want, put commas in between. You don't have to. If you don't put commas, however, you need to put spaces. Here the space is mandatory if you don't put the comma. Something else happens though if you put semicolon. That's why it's actually a good habit to put a comma when you need to. If you put comma, it's going to basically create a row. It's going to put the elements one next to each other. If you use semicolon, it's going to create a column. It's going to put the elements one below the other. That's very simple, but very important for you to remember. Okay? And if you type these things in Matlab, it should come out exactly like that. And remember, if you put semicolon at the very end of these, you don't get the output. Okay? But you still create the variable. There are some predefined matrices. Sorry, there was an animation problem here. But you can create, for example, a matrix full of ones by typing x equals 1, and then you want to specify the number of rows, in this case 2, the number of columns, in this case 4. If you type this, you should get exactly a matrix which is filled with 8 ones. You can do the same but with zeros. Okay? So you create this time x with 3 zeros. And you can play around and change the number of rows and columns. And you can create a variable, matrix, where you have, along the diagonal, you have ones and all the rest is zeros. And you do this using I, the function I. And finally, before I showed you, if you want to put, for example, into x all the elements from 1 to 4, you can specify them. You can write 1, 2, 3, 4. Okay, this quickly gets annoying, especially if you want to go to 100 or to 1000. Yeah? There's a better way, which is you use a colon between the first and the last number. And if you just do this, Matlab knows that you need to advance, in this case from 1 to 4, in steps of 1. Okay? 1 column 4 goes from 1 to 4 in steps of 1 and puts them all into x as we asked them to do. But you can also advance with steps of 2, for example. And that's what this last example shows you, where we define x going from 2 to 8, but in steps of 2. So this time you don't need just one column, you need 2 columns, and in between you tell them what the steps look like. So the output is 2, 4, 6, 8. Everybody following? Yeah. So now, if you want to know how big your array is, well, you can look into the workspace, and maybe by now you can see the workspace. It should tell you the number of rows by the number of columns. But you can also type in the command window, for example, using the function size. Yeah? So if you create now, please create with me x equals this, yeah? And if you then type size of x, it should give you this result. And can somebody tell me what this means? How many rows and columns do we have here? 2.
4 rows and 1 column.
Very good. Good answer. So now if we say you can also get the size of something which you haven't even created, and you can put that size into a new variable. So that's what we're doing here. So here basically I'm looking up the size of this vector, 2, 4, 6, without creating the vector. And that size I'm going to put into the variable s. So the variable s has the size of this vector, which was never created, which is 1 row and 3 columns. Correct? And if I put columns, semicolons instead of comma, I will have the opposite. I will have 3 lines and 1 column. Okay? By the way, we're going to give you the slides, so don't worry, you don't have to write down everything. Okay, if you don't specify the variable you want to put something in, stuff is going to go into, per default, it's going to go into a variable called a and s. So, for example, if I had a vector with 4 columns, so 2 semicolon 4 semicolon 6 semicolon 8, I take the size of it, but I do not specify where I want to put it. Well, in that case, the output goes automatically into the variable a and s that Matlab creates completely on its own, and that's good, but it can also be dangerous, because if you think that it's a good idea to save stuff into a variable called a and s, well, it's not a good idea, because it's going to be erased each time you do something without specifying the variable you want to put it in. Okay, so since we're talking about size of arrays, one way to do it is with the function size. One another way is to do it with the function length. Yeah? And if you have a vector, it's going to give you just one number, so it's going to tell you the number of rows. If you have a matrix, two-dimensional matrix, and you use length on it, I think it will give you still just a number of rows. So maybe you can try out.
It gives the maximum.
Oh, it gives you the maximum?
Yeah.
Okay.
Maximum you can row some columns.
Oh, yeah. So length is mostly good if you're working with vectors. By now you should know that a vector is just one column or just one row. That's a vector. Yeah? Yeah? So length is good on vectors, but not good on matrices. Because apparently it gives you just one dimension, and the biggest one. So if the matrix has more rows than columns, it's going to give you the number of rows. If it has more columns than rows, it's going to give you the opposite. Okay. So from time to time you will see these green try things, which is just one way to encourage you to try out everything I'm talking about. So now that we know how to create arrays and how to look up their sizes, well, let's learn how to concatenate them, how to bring them together. So let's create X like this. So it's a matrix, a two-dimensional matrix. And if you type size, we should get 2, 2. That's one way of concatenating if you want numbers. Another way, however, is say we now create another variable. In this case, it's a vector, y. Yes?
When we do this, we have to clear all the command, all the previous commands.
You can, but if you don't, it's just going to erase x.
This one, last one.
Yeah, so if you created x before, now you type in that, your previous x is lost,
Okay.
and it's going to create a new x.
Okay.
But you can also type before clear space x, and it's going to erase x. Or clear space all, it's going to erase everything. Okay, anyway, what I'm doing here is, after I created x, which is a 2 by 2 matrix, I create y, which is a vector. It's just one row. Okay? And now in Z, I concatenate x and y. And I concatenate them by putting y underneath, below x. Because I'm using the semicolon. So if you compare now, you still have x on top, 2, 5, 3, 8, and at the bottom we have 10, 11, which is the number, which are the numbers of y. Now, Tiziano, do you think that we can create z prime by concatenating x and y with a comma instead of a semicolon?
No.
Oh, why not?
I mean, we wouldn't get the same result, but we can.
What would you get?
Let me find out.
Got it.
I think it will just continue from the last row.
Yeah, so you say we can, and it would continue here.
I think so.
Okay. Yeah, so actually that's a good question. Does it work and add zeros?
No,
It doesn't work, huh? It doesn't work. It would only work if we were to turn y. Because so far we have a two-dimensional vector with two elements, and we're going to try to put it next to it. So Matlab's not going to like it, but if you turn it, we could attach it next to it. Okay, we're going to see these examples later on. And here a fun example is that we can also concatenate the variable, which is the vector u here, with more numbers. And so in the end we get a longer vector. It's like we concatenate a vector with a vector we are creating. Okay. Oh, sorry, was that too fast? You guys did it so. Good. Okay, this is actually kind of the question I had before. So if we have x, which is again a two-dimensional matrix with two lines and two rows and two columns, and we create y, which now has three elements, and I want to put again y underneath of x, my left hand is not going to like it. Why? Because this has one element too much. Yeah? Too many. Try it. Let's see if it works. But you could play around it. If you added some zeros to x on the side, so now I take x, comma, which means I go to the side, and there I put a column of two zeros. Yeah. So it's a concatenation in the concatenation. You guys get this? So the smaller concatenation is taking two zeros and putting one below the other. Why below? Because it's a semicolon. Okay? So now I'm taking x, which is 2 by 2, and to the side of it, to the side because here is a comma, I'm putting this newly created column of two zeros. That's what happened here. And then, once I've done this, semicolon means I go below, I add y, which now fits, because y has three elements. Yes? So far we have concatenated using these square brackets, with either a comma to go to the side of the semicolon to go below. But you can also use the variables, the functions, horse, cat, or bird cat. Or just cat. And you can check them out. For example, if you type help space cat. Usually it works like that. You give the dimensions and then the two things you want to concatenate. So in which dimension you want to concatenate. The first dimension is going to be row below row. The second dimension is going to be the side. Yeah. So what I put right here. Yeah, okay. This is just to make it clear. Before we were using this type of writing, square brackets with comma, which is the same as the function cat going into the second dimension. This is wrong, right? No, this is correct, because we go to the side. Sorry. So first dimension is going down, here's semicolon, and second dimension is going to the side, comma. Okay? Actually, as long as you stay in 2 dimensions, you're going to use most of the time the square brackets and comma and semicolon. Cat becomes more useful if you go, for example, to 3 dimensions. And that's what we're going to do now. So, you create again X. If you can reuse the X we had before if you want. It's a 2x2 matrix. Now I create Y, which is also a 2x2 matrix. So that's important. It has the same size. And now we're going to concatenate them first, as before, in the. That's actually not. Oh, that's in 2D, but it's actually in the first dimension because we're going below. But we can also concatenate them in 3 dimensions. So now I call it z underscore 3d, just a name. This variable is going to contain what? X and Y attached one behind the other. Imagine you have 2 sheets of paper. One is X, one is Y, and I'm going to put them like this in the 3rd dimension, one behind the other. That's what we're doing here by using the function cat, open parenthesis, 3 because it's in the 3rd dimension, and then the 2 matrices we want to concatenate X and Y. If you do this in the type size of this variable which you created, you will get not 2 but 3 numbers. It will tell you that in each dimension it has the size of 2. It has 2 rows, 2 columns, and 2 sheets. How do you call it? I call it pages. Pages. Did that work for everybody? Yeah? Okay. Good. So we know how to grade them. We know how to concatenate them. And now we want to index them. So it means access specific elements of the grading. Again, this is our X matrix. And we use round brackets to access elements of the matrix. For example, X, that's the name of the variable, X, and in parentheses, 1, 1, gives me 2. Why? Because I take the first row and the first column. So these 2 numbers here, they give you the index of the row and the index of the column. 2. And if I were to ask for x 1, 1, 2, I would get 5 because it's the first row by the second column. So it's the number 5. Okay. And just one more example, x2, 1 would be the second row and the first column, so it's the element 3. Oh yeah, and you can try this out. If you ever ask, for example, x3, 1, it's going to tell you no, because it's outside of the size of the matrix. Oh, that's quite interesting. So far we saw how to use the index of the row and the index of the column. But Matlab basically perceives matrices as one big vector. Yeah? Even though it's not a vector, it's a matrix, for Matlab, this goes down the first column, then it goes up, and down the second column, on the third column. That's how Matlab sort of conceives this matrix. And because of that, you can basically, you don't need to give the number of rows and columns, you can just give the number as if you were going down one big column. For example, x1 is still 6, and x2 is 9, and what is x3 going to be? Obviously 7, right? Because we have 6, 9, 7, 7 is the third element. And, what did I do here? X of y. Okay. So you can create a variable, say the vector y, which contains the numbers 1, 2, and 4, and you can use that variable y to index those elements in X. So if you try it, you create y equals 1, 2, 4, and you say x of y, you should get 6, 9, and 10. Is that what you get? Oh, you cannot see it. Just create y equals, and then you create the array with the square brackets, 1, comma 2, comma 4. And then x, open parenthesis, y, close parenthesis. Yeah? Good. However, don't get confused because before so I showed you this, giving the number, you give the number of the row and then the index of the column. Now, if you use the single indexing, you cannot, use comma and colon. It's not going to work. It's going to give different results in the sense that x of open parentheses, square brackets, 1, 2 is going to give you the elements 1 and 2. But if you type it with semicolon, it still gives you the element 1 and 2, just turns them around. And what is this? Okay, so
It's the same, just
yeah. Just another example. So I often have other examples here which you can just try out also later on. Oh, this was when I gave the class last year. I had a discussion about semantics, and so you have been hearing me saying colon and semicolon. So that's a colon, and semicolon is the one which we use to concatenate to put one below the other. But a colon is also a part of your intestines, so it's just the same, and get used to it. This being said, we already learned that you can define a range just by putting a colon in between two numbers. So x 1 to 3 is elements 1 to 3. You can do this range instead of 2. So that's a little bit repetition from before. You can also have the steps going into the negative. So 4 to 0 going down by -1. And obviously that is useful when you index. For example, you could access the elements 1 to 2 of x. In this case, it would be 1. Wait, x is, okay, because we changed x. I was looking up here. So if x is equals to 1, 3, 5, 7, the elements 1, 2, 2 are the elements 1 and 3. I'm almost finished with the slides. And then we're going to have a short break, okay? So now let's create a bigger X, which has a 3 by 3 matrix. And here I could use, let's say, the colon to say I want in the third row the elements 1, 2, 2. That's how we do it. So first we get, remember indexing, when it's not single indexing, it's usually you get the number of the row, and the number of the column. But it can be more than one column, it can be 2 columns or more. And you can even put just a colon to specify that you want everything in that dimension. So now here I'm saying x, and I want all the rows of the second column. It will be 22, 25, 18. So that's really cool, actually. Yeah. And if you have a matrix, and you type x and parentheses colon, you get the entire content of the matrix, again, in that form, as if it were a vector. I told you before, no? So he goes down 6, 9, 7, 10, 8, 11. And if I go just back one slide, this was the way we were using before. We'd say colon for all rows, comma, and then the number of the column. Well, now I'm giving him just a colon, and it gives me everything in one vector. And there's another index which is cool, which is the end index. So if you have, for example, a vector and you type x and it's going to give you the last element. You can also use this as a number, as if it were a number. So you can say n minus 1. If, however, you take the minus 1 and you put it outside the parentheses, it's going to be different. Because x n is 4. If you put the minus 1 outside, it's going to be 3. Well, it's going to be the same in this case. Okay, that's another time. You can also, you can say I want all the x's from 1 until the one before last. And yes. So here take the first row and the last column. And here take just the last element, and this is single indexing as if it were one in one vector. Let me just see how much I have left. I thought I were done. Okay, just 2 slides left. You can manage, right? Okay. So now if you want to change the content of an array, we have an array x, which is 2 rows by 3 columns. And I'm going to first index a specific element in that array. So x2 is actually 9, but I'm going to tell him turn it into 12. Yeah? And so now x is going to look different. It's going to be 6, 12 instead of 6, 9. And you can change many elements at a time. For example, here I'm taking the first 3 elements, which which are the first 3 elements of x, of this new x?
The first element?
The first 3 elements.
6, 12, 7.
Yes. And I'm going to tell him, change them to 3, 4, 5. So now we have 3, 4, 5, 10, 8, 11. Okay? That's the basic way to change parts of your matrix. If you try to change something which doesn't exist, well, it will add it to your matrix. Okay? So in this case, if x is 2 by 3, and if I say x1, 4, so it would be first row, but the 4th column, which doesn't exist, turn that into 12. He does it, he adds 12, but he needs to put something underneath to make it even. And he puts 0. However, if now I want to change x, the first row and all the elements, which are 4, and when I replace it with a vector which is only 3 elements long, Matlab's not going to like it. It's going to give me an error. Okay, and so this is it for the slides of today. And if everybody agrees, I propose we do 3-4 minutes of break, then come back and do exercises. Yeah? Cool.